All right, let's see, A, B, C, D, A. Okay, point A is at 350 kelvins. Right, and because we know the pressure and the volume, we can find the moles at that point, right? So PV is nRT, so therefore N is PV over RT. Right, so at A, we're going to figure it out from this stuff here, right? It is, N is, that's 9 times 10 to the 5th, right? V is 2 times 10 to the minus 3rd, right? R is 8.31. And what does it say? The temperature is 350 at A, right? All right, so let's do that. Let's calculate what that is. 9E5 times 2E minus 3 divided by 8.31 divided by 350. And that is 0.618875 moles. I'm going to take the time to store that in alpha N. All right. So what is the temperature at point B? Well, the easy way to do this is, notice we're at 2 times 10 to the minus 3rd, and we go to 6 times 10 to the minus 3rd. So that's just going to be 3 times the temperature. So 3 times 350 is 10,000, 1,000, right? Okay. But let's imagine you don't believe me, right? Well, T is going to equal, from this is going to be PV over NR, right? So you could also do it this way, right? So at B, the pressure is 90, that dies hard, 95. The volume is 6E minus 3. The moles are 0.618875. And R is 8.31. I'll bet if I do this, 9E5 times 6E minus 3 divided by the number I just got for moles divided by 8.31 is 1050. I encourage you to use shortcuts like this, okay? Let's see, what is the pressure and temperature at point C? Okay, we got to know what this is. Let's see, point C. Point C. BC is adiabatic. Okay. BC is adiabatic. Okay. So we want to find the pressure and temperature at point C. The pressure. Okay, so what we're going to do is we are going to use this guy. Okay, and we're going to go from here to here, okay? Because that's an adiabatic process, right? So we're going to go 9E, on the left side will be B here, 9E5 times 6E minus 3 is equal to, and then we don't know the pressure at C, right? Or B. Oh, C. All right. And then the volume, though, we do know the volume is 9 times 10 to the minus 3rd. To the 5/3. Oh, this is to the 5/3 as well. Okay? So now let's solve for the pressure at C. So I'm going to go 9E5 times 6E minus 3 raised to the 5 divided by 3. And then I'm going to divide by, right arrow, divide by 9E minus 3 raised to the 5 divided by 3. And I get that the pressure at C is 457,885. 0.697 pascals. Or let's see, 1, 2, 3, 4, 5. 4.58 times 10 to the 5th pascals. That would be proper scientific notation, right? Okay, so what is the temperature at that point? Okay. Let's see, we'll use this. Temperature is PV over NR, right? So temperature is P, which is this, right, times PV. So V is, what is V? V is 9 times 10 to the minus third, right? Divided by PV is PV over NR. So it's, our N is 0.618875. I'm just going to use the number on my calculator. And then R is still 8.31. All right, so that number on my calculator times 9e minus 3 divided by, let's find the moles. Where's the moles? There's the moles. No, is that? Oh, that is the moles. Divided by 8.31. And I get 801.3 kelvins. 2999 or something like that, right? Kelvins. So 801 kelvins is close enough. State the temperature of point D. Well, this is DA is isothermal, right? Isothermal means constant temperature. So if you go from D to A at a constant temperature, that means that D has to be the same temperature as A, right? Okay. So D is also 350, right? Now just notice if they say show that this is isothermal, what you would do is just go PV equals PV, right? So here we have 9 and 2, that's 18, right? Okay, here we've got 6 and 3, that's also 18. Here we've got 3 and 6, that's also 18. And here we have again 2 and 9, which those multiplied by each other are all 18, right? So the temperature is 350, right? Because DA is isothermal. So it's super nice. I don't know if you can hear the conversation in the background. All right.